Hello, in this video we're going to look at solving quadratic inequalities. If you notice at the very top of the page, there are 5 steps in how we are going to solve quadratic inequalities. The first step is to rearrange the terms of the inequality so that one side is set equal to 0, or I guess less than or equal to, or less than or greater than or equal to, because we're talking about inequalities. So you essentially want to move everything that is a constant or a term involving the variable over to the left-hand side or right-hand side of the equation, so that one side, all that remains is a 0. Step 2 is going to be to factor the quadratic to find the x-intercepts. Step 3, using the x-intercepts and whether the parabola opens up or down, we're going to sketch a graph of the parabola. So what that means, we can tell whether a parabola opens up or down depending on the leading coefficient, or a value. If a is positive, so greater than 0, it opens up. If a is less than 0 or negative, it opens downwards. And then you sketch a graph of the parabola. So step 4 is looking at the inequality sign. For inequalities where the quadratic is greater than or equal to or greater than 0, you shade where the graph is above the x-axis. For inequalities where it's less than or equal to 0 or less than 0, shade where the graph is below the x-axis. Then you write your answer in interval notation. So we have the example for number 1, solve the quadratic inequality. It's already been factored for us. That's excellent. So we've already done half the work by not doing nothing, because we already have it set, one side set to 0, so step 1 is done. It's already been factored, so step 2 is done. So we're about 2/5 the way done. To solve for the x-intercepts, we're going to set each of these binomials equal to 0. X is x minus 2 equal to 0, and x minus 5 equal to 0. So we end up getting that x equals 2 and x equals 5. These are our x-intercepts. I'm going to go ahead and say we'll have a solid dot on these intercepts because of our inequality sign. That also implies that we're going to have brackets when looking at our interval notation. Now, the leading coefficient on this, if I were to multiply these binomials out using either the FOIL method or the box method, whatever method you want, you would end up having a positive leading coefficient of +1, and so therefore our parabola opens upwards. So I'm going to draw a quick sketch of this parabola. It's going to open upwards. It has x-intercepts at 2 and at 5. So the y-axis would be right here. 1. Okay, cool. And so because we're looking at the quadratic inequality where we're dealing with a less than or equal to 0, we're going to shade where the graph is below the x-axis. The graph of this parabola is below the x-axis between 2 and 5 inclusive. And so our interval would be from 2 to +5. Okay. Oh, but it's inclusive, so we don't want parentheses, we want brackets. There we go. If you want, you can shade underneath just so you know what's going on. If it were, where is it above the x-axis? If it had been, what if it's greater than or equal to 0? Same parabola, same information. Then you would have ended up having the intervals from -infinity to 2. Unioned with 5 to infinity. So because this is above the x-axis for all of these x values. Anyway, we'll make sure you're looking, I guess my point is make sure you're looking really carefully at your inequality sign. Also remember that if our inequality is a less than or greater than, then we would use an open circle on these intercepts, and then they would not be included, so we would use parentheses. So just a reminder of our inequality rules. Let's look at number 2. Number 2, again, this is already in factored form. It's already been factored out. The leading coefficient, if I multiply this out, would be greater than 0, so my parabola is going to point upwards. Okay, so we're looking for where x times x plus 4 is greater than 0. So we're going to set each of our terms, x equal to 0 and x plus 4 equal to 0. Or you could use the inequality sign. That's also fine if you want to keep track of that. So we already have x must be greater than 0, or x plus 4 must be greater than 0. But I just like to set them equal to find those x-intercepts. Okay, so I actually just leave these as equals to find the actual intercepts, and then I think about what that means after I solve. So we have the intercept x equals 0, and we have the intercept x equals -4. I did that by subtracting 4 from both sides. Those would cancel, and so we get x equals -4. So those are our intercepts. So if I were to draw a quick sketch of my parabola, this parabola would have intercepts at -4 and at 0. Okay, and we would have a parabola there that's pointing upwards. Again, it's just a sketch, it doesn't have to be perfect. And then we want to figure out, where is this quadratic greater than 0? So where is this quadratic parabola above the x-axis? Well, that's from this point up, non-inclusive, so that should be a hollow circle. I'm going to do like a little parenthesis there. And from this point up, this is where the graph is greater than 0. So therefore, my values are going to be from -infinity to -4, not inclusive because of the a greater than sign, union with from 0 to +infinity. It's kind of like looking at the range that satisfies this parameter. On question number 3, we do have to start out the beginning of the steps, because if you look here, neither of the sides are equal to 0. And so what I need to do is I need to move this -3 over to the left-hand side. So I'm going to add 3 to both sides. That will cancel to 0. So we end up having x squared minus 4x plus 3 on the left-hand side must be greater than or equal to 0. Our leading coefficient on this is a +1, so that's greater than 0, so our parabola is going to point upwards. Okay, now I need to factor this. This one's a nice one. We're looking for two numbers that multiply to get +3, but add to get -4. So they are both gonna have to be positive, or they're both going to have to be negative to get this +3. But in order to add numbers together and end up with a -4, we're going to have them both be negative. So our factors of 3 are just 1 and 3, so both of those will be negative. If I multiply those together, I get +3. If I add them together, I get -4. So this factors into x minus 1, x minus 3 is greater than or equal to 0. Next step is to find our x-intercepts. So I'm going to take each of these binomials and set them equal to 0. X minus 1 equals 0. X minus 3 equals 0. I'm going to solve each of these for x. So I get x equals +1 and x equals +3. So my parabola is going to look something like this. The first intercept is at x equals 1. The second one is at x equals 3. So this one is looking for where is this parabola greater than or equal to 0. So I'm looking for where is the graph above the x-axis. That's from here and here. Now remember, this goes outwards technically based on these arrows indefinitely. So my x values where this is true, where it is greater than or equal to 0, it's from negative infinity to 1 inclusive because of the greater than or equal to sign, unioned with 3 to infinity. All right, let's look at this last one. This is a quick video. There's only one of these. Hopefully it'll help. This one we have to move both of these terms, 15 minus x, over to the left-hand side. So we have, we're first gonna add x to both sides. So we get 2x squared plus x is less than 15. I'm gonna subtract 15 from both sides, and we end up getting 2x squared plus x minus 15 is less than 0. Now, our leading coefficient on this one is positive, so our parabola is going to be facing upwards. To factor this parabola, I'm going to use the AC method, so I'm going to multiply 2 times negative 15, which is negative 30. And then I'm going to think about all the factors of negative 30. I have, and knowing that it's negative, one would have to be positive, one would have to be negative. So I have 1 and 30, 2 and 15, 3 and 10, 4 won't work, 5 and 6, 7 doesn't work, 8 doesn't work, 9 doesn't work. Okay, and we're back at 10. So how do I get a leading coefficient of 1 with these values? Well, we would have to use 5 and 6. And one would have to be positive and one would have to be negative. Since my x term has a positive 1 value, the bigger value would need to be the positive. So essentially we can separate this into 2x squared plus 6x minus 5x minus 15. Again, this goes back to like factoring by grouping. Because we are separating this term and rewriting it as these two terms sum together because they're equivalent. 6x minus 5x is equal to positive or plus x or positive x. And so we haven't actually changed anything. We're just rewriting it in a way that will make our lives a little bit easier because now we can factor out a 2x from these terms and a negative 5 from these terms. And we end up with an x plus 3 that we can now factor out. So we get 2x minus 5 times x plus 3 is less than 0. So now I'm going to use that to solve for my intercepts. We have 2x minus 5 equals 0. Add 5 to both sides. So 2x equals 5. Divide by 2 on both sides. We get that x equals 2, or 5 halves. There we go. You could do the division, you would get 2.5, but I'm just going to leave it as 5 halves. We're going to do the same thing with x plus 3. Set that equal to 0, subtract 3 from both sides, and we get that x equals negative 3. So these are our intercepts. So drawing a sketch of our parabola. It has intercepts at negative 3 and at 5 halves, which is 2.5. So we look at this and we see that this would point upwards like this. Pretend like that was actually through that point. And we're looking for when is this quadratic less than 0. So that's going to be between negative 3 and 5 halves. It's not going to include those values because of the inequality sign, and that is our interval. Hopefully this helps. If you have any questions, email me and let me know. Just be mindful, all the examples we've seen so far had a parabola facing upwards, the concept would be the same thing. Like if I had a quadratic, I said, when is this less than 0? But it had a leading coefficient less than 0, so it was facing downwards. And let's say this is x1 for the first x-intercept and x2 for the second one. This would be, where is this quadratic less than 0? So that's from here to here, so that's these x values. Okay, so it would be from negative infinity to your x1 union with x2 to positive infinity. So the concept is the same. Just because we didn't see any examples with a negative leading coefficient, the concept is the same. All right. Good luck. Thank you so much. Bye.